Today I want to go through creating some VLANs and show you how to segregate your network into 2 or more segments to improve your overall internet security. I'll show you how to separate different rooms, computers, or even IoT devices and help increase your security to a new level. To learn more about how to do this, then watch the rest of this video. If you haven't already done so, then please subscribe and don't forget to hit that notifications icon. Before we get started on how to do this, let's talk about why you should do this. There's a number of reasons we should consider for doing this in our homes. The first and arguably the most common is IoT devices. With the heavy influx of IoT devices into our homes and their questionable security, it makes perfect sense to break those items off onto separate networks just to keep them isolated from other devices. Also, depending on how many people are using the network, having a family wired and wireless network makes a lot of sense as it helps protect your main network. For example, if you have other people living with you, you don't want them to have access to your network, and that way if something happens, such as ransomware, your devices will most likely be protected even if theirs get attacked. Sure, you could use a guest Wi-Fi. That also has some interesting side effects, and it typically applies to only Wi-Fi devices and not wired devices. So now that we have some good reasons on why we should do this, let's get started on how to do it. The sequence you do this in is not super critical, but I've detailed this the way that I would do it. But in reality, as long as you complete all the steps, you should be fine. So before we actually go through each step with each piece of hardware, let's first talk about the concept of what we're trying to apply here and kind of how it's going to work, just so you can better relate it to your own particular hardware. So if we look at this quick diagram here, I'm going to start working backwards. So the intent here is to get everything out through the router into the internet. But prior to that, we want to make sure that there's some level of isolation. So we want to create some VLANs. Now, the way the traffic's going to flow is in the wireless access points, all the VLANs will be created there. So the wireless access points will parse out and provide the proper VLAN ID, which will get fed into the router, which will allow all your wireless access to go out. Prior to that, we want to use a managed switch to provide some isolation for our wired devices. What I have here is a managed switch, and you can see that we've broken this down into and isolated a couple of ports, which I'll show you how to do that here in just a minute. But we've got port number 3 here, which is VLAN ID number 80, and that's what we'll be using as our IoT test VLAN. And then I have another one called VLAN ID 40, which is for the family network, and then all the remaining ports of that switch are direct. So we basically, all we did here is carve out 2 ports out of the managed switch. And depending on your switch, how many ports you have available and what your plan is, you can create as many of these as you want. You can have 4 or 5 ports assigned to VLAN ID and so on. So it's really totally up to you and your hardware configuration. Now, in my case, because port number 3, I've only isolated 1 port, there'll be a dedicated switch coming into that port. So everything that's plugged into that switch will get tagged with VLAN ID. That also holds true for my family net switch, which is actually taking feeds from multiple rooms, routing it into one switch, and in turn to the managed switch. And the reason I do that is because I only have so many ports on my managed switch. I could actually go all the feeds directly into the switch, which is what many people do. But because of the sheer number of cables and devices that I have, I've opted to do it this way. So I've got an interim switch that basically provides only one uplink to the managed switch. So looking at the data flow here, we've got our IoT switch that's going to come into port 3, basically untagged or unaltered. As it hits port 3, it's going to get tagged with VLAN ID and in turn go to the router. The router will interpret the VLAN ID and based on the firewall rule, will allow your traffic to go out. And the same applies for the family net. It'll come in, get basically into the switch, untagged. It goes into port number 2 of the managed switch, comes out tagged with the VLAN ID 40, The router interprets VLAN ID 40 based on our configuration and allows traffic to go out to the internet. That's basically the overview. Now let's get into how we actually do this. So the first thing I want to point out before we do this is that you'll actually have to substitute some of the specific instructions for your own individual routers or switches and your access points, depending on the manufacturer that you use. The concept will be almost identical, but your step-by-step instructions may vary slightly depending on the hardware you have. So as we go through this, I'm going to go through this with my hardware, kind of point out what you need to look for. So the first thing we want to do is we need to create an interface, whether that's I'm using Sophos, but the concept is the same in pfSense, or most of the better higher end home commercial routers also have the capabilities of creating a VLAN interface. So what we're going to do here is add an interface. I'm going to add a VLAN. So I'm going to call it IoT test. It's going to be bound to port number 4. Again, this varies from router to router. In my case, or my Sophos router has actually multiple NIC ports, and my actual LAN network comes in on port 4. So we're going to pick port 4 for me. In your case, it might be port 1, or you may not have a choice because there's only one port. We're going to give it a VLAN ID, so I'm going to put 80 for this particular test. So I'm going to give the IP or the interface, the VLAN interface that we just created, a static address of 192.168.80.1, and it's going to be a /24. We'll leave that alone. There's really nothing else we need to change here, so I'm going to go ahead and hit save. Okay, it says it saved it. Now the next step we have to do is, this by itself won't do anything unless we actually give it some DHCP range. So we want to be able to, whatever comes in on VLAN 80 needs to be assigned a DHCP address. So I'm going to go over to DHCP and I'm going to click add, and I'm going to give it the same name. I'm going to select the IoT interface we just created, and I'm going to give it a range. So I picked 100 to 200. I usually don't go below 100. That leaves me some room to create some static IPs. Okay, and then down here, we're not going to change anything. Everything's going to pretty much stay the same as the default. So what we've done here is create a DHCP for this new .80 range for the IoT VLAN interface. I'm going to hit save. Okay, so now we've created pretty much everything we need to create in the firewall. There's one last thing we need to do, and we just need to make sure that we have a rule for it. And again, this part will vary significantly on a router to router. So you'll have to look up what steps are needed in your own particular hardware. Pretty much guarantee that you're going to need to create the VLAN interface and a DHCP. Beyond that, you may or may not have firewall rules to deal with. I'm going to go ahead and just clone one of these existing rules here. I'm going to call it the same thing. We're going to accept traffic. Okay, so I've created a network with the new VLAN interface. Click save, and we're all set. So now the firewall is complete. It's time to go to the next step, which is our switch. In order for the traffic to pass into the firewall, we have to have a VLAN interface into the firewall, and it has to have a DHCP. But the step before that is we have to get the traffic to the firewall, and that's usually done through a managed switch. So your last step to make your managed switch aware that it has tagged IDs coming through. So you can see I've already created one here for 40. So let's go ahead and create one real quick for 80 to match the interface that we just created. This happens to be a QNAP switch, extremely easy to set up VLANs. Your switch may be different. You'll have to look up the specific instructions, but I'm going to go ahead and click add. I'm going to call it 80. Okay, so what we have here is port 3 will be assigned with the VLAN ID. Everything that comes into that port will get a VLAN 80 tag on it. What comes out of it will be tagged. So I'm going to put port 3 as untagged. And then once the traffic actually goes into port 3 and gets tagged with the VLAN 80, it needs to be able to be let out. So it has to go through the uplink without any obstruction. So in my case, my uplink is port 9. So I'm going to go to port 9, and I'm going to actually tag that port. So everything that comes physically into port 3 that's random, whatever it's coming from, we'll get a VLAN tag of 80, go through the switch, And the uplink will allow all the tag traffic to go out to through port 9. So basically what comes into port 3 untagged will end up getting tagged, going to the uplink port number 9 and allowed to pass through. So we're going to go ahead and save this. So as you can see now, we have our physical port number 3, which currently is empty, is marked as untagged. So everything that goes into it doesn't need to be tagged. Anything can be plugged into it, including a small switch, which is what we're going to do. And then port number 3 will get the tag and then be allowed to pass through port 9, which is my uplink going out to the router. So I hope that makes sense. We're going to show a chart here in a second just to kind of re-emphasize some of this. The final process in making all this work is to actually configure our Wi-Fi and to create a Wi-Fi network that will actually communicate through the VLANs. I'm using the UniFi controller and UniFi access points. Your hardware may vary and you'll have to figure out if it actually supports VLANs. Most access points do. The first thing in the UniFi that you need to do is to actually add a network. As you can see, I've already created 2 networks. One is my default LAN and the other one is a family network, which is also a VLAN, which we'll talk about when we put all this together. So I'm going to click on Add Network. I'm going to give it a name. To remain consistent with the rest of the VLAN configurations we've created so far, I'm going to call it IoT Test. I'm going to go down to Advanced, and we'll give it the VLAN 80 that we've been using all along. Then I'm going to scroll to the bottom here, and I'm going to say no DHCP server. And the reason I don't want a DHCP server is the DHCP server has already been assigned through my router. So I don't need to have duplicate DHCP servers. The other thing I want to do here is change the default address that comes up to 80. So this is going to be a 192.168.80.1/24. And that should be all I need at this point. So I'm going to click on Add Network. It says it was successfully added. As you can see, the IP range is correct and it's what we want. So the last thing I have to do is go up to Wi-Fi networks and actually create the Wi-Fi we're going to use. Okay, so I'm going to click on Add Network. I'm going to give it a name. Stay consistent with the rest of our VLAN ID. I'm going to give it a password. And here I'm going to select the network that we just created. Now, if I go under Advanced, I'm going to make sure this is clicked on both. You can create either a 5 gigahertz only or 2.4 gigahertz only if you'd like, but I'm going to leave it on both. And then that should be it. So I'm going to click on Add Wi-Fi Network, and it's now been created. So you can see the IoT test is here, and we're ready to go. So now we've completed all the steps of setting up our VLAN. Now we need to make sure it all works, and then just kind of go through the concept of what just took place. So let's get into testing this thing. So the first thing I'm going to do to simplify things a little bit is let's test out the Wi-Fi networks that we created. So we'll start with the one that we actually created on the video. So I'm going to go over to my Wi-Fi settings, and I'm going to pick the IoT test that we created. I've already typed in the password, so I'm going to go ahead and click Connect. And now it says it's connected. So let's take a look at the properties real quick. And as you see from the screen, we are getting the proper IP address. So we are getting a IP address in the .80 range, which is what we wanted. We happen to be getting the first one in the DHCP server. So everything looks like it's working okay. So now let's actually test the internet, and then we'll test for isolation. Let's launch a website. So it looks like everything is working. The next thing for us to do is to make sure that we have the isolation that we're looking for, because that was really part of the big purpose here. So let's see if we can ping any of the other devices. So as you can see, it timed out. It did not get any response. So now let's try a different device just to make sure with the same result. So effectively, we're getting the isolation between what I'll call my main network and the 2 VLAN networks that we just created. And just to confirm, we're going to actually go the other way. So I've logged into my main wireless and to see if I could actually access a device on the VLAN. And as you can see, there's no connection there either. So we've got complete isolation of these networks. And just as a final test, while we're here in the Wi-Fi section, I'm going to go ahead and test the other one that I actually created, because I did create 2 of them that I'm actually going to use. So I went ahead and created a family net as well. So what I'm going to do is let's look at the properties here. And as you can see, I've got a .40 address, which is exactly the range of the VLAN that I set up. And again, just to verify that it's all doing what it's supposed to do, I'm going to go ahead and test out going from VLAN to VLAN, and that's not communicating. And then just to give it that final confidence level, I'm going to go ahead and test it out to the main network. And again, we have no communication, and we have basically segment isolation. So there's no communication between any of the VLANs to the main network or vice versa. So we've achieved what we needed to do, at least on the wireless. Let's get into testing the actual wired section now, where we can test out the ports that we created in the managed switch and kind of use a cheap low-end switch to demonstrate how we can attach an entire room into one of the VLANs, which is really what I'm going to be accomplishing. Okay, and as a final test, what we want to do now is test the hardware section or the wired section of the VLANs to make sure that everything is working the way it's supposed to. And if you recall, we did a IoT test VLAN on port number 3 of one of my managed switches. So what I'm going to do now is actually plug into that switch, and then we're going to test to make sure that it's picking up the same range of IP addresses that it was before. I've turned off the Wi-Fi on this computer so that I'm only wired into the switch directly. All right, so I went ahead and plugged it in. Let's go ahead and check the details. And as you can see here, I've got a .80 IP range, which is exactly what I wanted. So in summary, what we've done is plug into port 3 of my managed switch, which we created for the purposes of IoT isolation. So we've tested the wireless, and now we've tested the wired section. So everything that's being plugged into port 3 or into the IoT SSID is now being funneled through the VLAN. So it's doing everything that we need to do, and we can scale this. To demonstrate that, I'm going to actually attach a small switch to it and then show you how that works. And it's nothing complicated. It's just basically how a switch works. But since we're feeding it into port 3, everything that we plug into that switch will actually yield the proper IP address. Okay, so the next thing that we want to do is actually plug in a regular standard low-cost switch just to see what happens. We're going to go ahead and put in a patch cable that runs from the switch now over to port 3 that we created. So what we've done here is extend port 3 into a separate switch so that we can kind of simulate pulling one of these standard switches from another room. Okay, so we're going to go ahead and plug the computer in now and make sure that it's going to pick up the correct address. So as you can see, after it's redetected, the entire switch is now being able to pick up the 80.IP range. So we've successfully expanded port number 3 into a low-cost switch. So if you imagine the switch being located in another room, they could easily be connected to one managed port. Now, of course, as I mentioned before, if you've got a bunch of managed ports, you can do this a lot of different ways. This is just an example of how you can actually extend the number of ports with only a small managed switch. Okay, so to better illustrate how this kind of all works and how the data is going to be flowing, let's take a look at this quick chart. So if we look at this, we have a couple of rooms that each have an unmanaged switch. They're each going to get basically routed to your managed switch, which has been identified as VLAN 40. Down here we have a IoT switch, which will be tagged as VLAN 80. So the data is all flowing into the managed switch. In addition, we have our Wi-Fi access point, which also goes into the managed switch, but it's untagged because the Wi-Fi access point already has the VLANs identified in it. So the traffic's just going to flow from all 3 of these directly into the firewall, which gets parsed out in there. So the individual VLANs will get distributed into the firewall so that everything gets the proper rule. And if depending on your firewall, of course, you've got to create rules for each one of these. So at the end, we'll get VLAN ID 40, which will support the different rooms, however many you have. They just will each need to have their own port assigned on your managed switch. And then VLAN ID for IoT devices, which will take care of both the wireless and the wired. Now, optionally, I've added a second access point here. So if your particular access point does not cover VLANs, you can use a couple of low-cost ones, one for your standard and then one for your IoTs. So that's another way that you can get that done. The easiest, cleanest, and most flexible way is to have an access point that supports VLANs, and most really do at this stage. As you can see from this configuration and the quick test that we did earlier, that once you figure this out and you've configured it to your own specific hardware, it's pretty easy to do, and it's very flexible, so you can scale and expand as much as you want. All you really need is a router that supports VLANs, an inexpensive managed switch, and an access point that supports 2 or more VLANs. Alternatively, as I mentioned, you can use multiple access points, but that seems to get more complicated, although it can be done. And once you do that, you're good to go. I really recommend that you do some level of network segregation, whether you use VLANs, multiple routers, however you want to do it, but you need to do something to protect yourself and your family. If you want to hear more on topics like this, then please leave a comment below. And of course, if you haven't subscribed, please do so and hit that notifications icon so you'll be notified when there's new material. Thanks for watching, and I'll see you on the next video.